Good morning, students. Today we are going to start the second lecture on the topic of sound in the subject of physics O levels. So concentrate yourself. We are going to start with a question. In space, there is no sound because there is no. Options are air, gravity, light, and magnetic field. So the right answer is air because sound needs a medium to travel. So A part is the answer. In space, there is no air molecules for the sound wave to be transmitted. The second question is, which set of the information about sound waves is correct? So the sound waves are longitudinal waves, and the speed of the air in the speed of the sound in the air is about 300 meter per second. So A part is the answer. So sound waves are longitudinal waves. The speed of the sound in the air is about 340 meter per second. The speed in glass should be faster than in the air because glass is a solid and the speed of the sound is more in solids as compared to liquid and gases. So A part will be the right answer. Here is another question. What is the correct order for the speed of the sound in air, steel, and water? Steel is solid, water is liquid, and air is a gas. So more thick, more denser the medium is, the speed of the sound will be more. So it means it will be greatest in steel, then will be the water, and then in the air. Then the order is from slowest to fastest is air, water, and steel. So look now, B part is the right answer because speed in solid is greater than the speed in liquid is greater than the speed in gas. Okay, here is very important point to be noted. Older people cannot hear as well as young people. Do you know how deaf people can hear sound? There is a special device called tactile hearing aid that changes sound vibrations into tickles that touch the skin directly and the bones indirectly. It looks like a portable cassette player and it can be worn at the waist or the arm. It takes some training to learn to hear the different tickles and know what kinds of the sound they represent. With practice and training, a deaf can learn to recognize the sounds of a few hundred words. Okay, the next thing that we are going to read is the refraction of the sound. Very, very important topic. Distant trains and traffic often sound louder and closer at night. The reason is this: during the night time when the ground cools quickly, air layers near the ground become colder than those above. Sound waves travel more slowly through this colder air because we have read that the more the temperature, more will be the speed of the sound. So the air layer near to the earth gets colder because earth at the night time becomes colder. So the air layer near to the earth gets colder. That's why the speed of the sound in the air layer near to the earth becomes slower. So look now, sound waves travel more slowly through this colder air. As a result, waves leaving the ground tend to bend back towards it. So look now, the sound waves tend to back. So tend to back towards it instead of spreading upward. A bending effect like this caused by a change in speed is called refraction. And this is the reason that the sound seems to be louder and closer at night. The next thing that we are going to read is the reflection of the sound. The compressions and the rarefactions of the sound are reflected back from the walls of the room. If the distance is long enough, you may hear a clear echo. Okay, the next thing that we are going to read is very, very important, that is echo sounding. Echoes are caused by the reflection of the sound. So this is the first point to be noted. Echoes are caused by the reflection of the sound. Echoes can be used to calculate. So there are two uses in the daily life of the echoes. Number one, the distance between two objects can be found out by using the echoes. And number two, the speed of the sound can be measured by using echoes. And here we are going to read some common uses of the echoes in our daily life. Ships can use echoes to find the depth of the sea. Fishing boats use this sonar. So look now, here is the sonar. Okay, the ships can use echoes to find the depth of the sea. Fishing boats use this sonar to detect shoals of the fish. If the shoal of the fish in the diagram swim under the boat, so when this shoal of the fish swim under the boat, these waves struck with them and comes back quickly in shorter time. So the persons at the boat know that there is a shoal of the fish under the boat. So this is the use of the echoes. This echo sounder uses a very high frequency sound. This ultrasound sounds with frequencies greater than 20,000 hertz is so high that we cannot hear it. Because ultrasound has a high frequency, it has a short wavelength. This means that it can be sent out as a narrow beam. If the waves are longer, they spread out more due to diffraction. Here is another application of the echoes in daily life. Bats and dolphins also use ultrasound and listen to the echoes to see their surroundings. So this is very interesting sentence if you have noticed. So look now, they use ultrasound and listen to the echoes to see. Listen to the echoes to see. So actually dolphins and bats send ultrasound waves when they travel, and if there is an obstacle in the way, the sound waves struck and come back, so they hear the echoes to see the objects. So this is the explanation. And here is a video that will make your concepts more clear.
This slow-motion video of a bat drinking from a pool of water was made by German scientists Stefan Greif and Bjorn Siemens. The pair set out to investigate the sensory cues that help animals recognize features in their environment. In this case, the ponds and rivers that bats use for orientation and foraging. We know a lot about how bats use echolocation to target insect-sized objects.
So the bats send ultrasound waves, and when it's struck with something, it comes back And in this way, the bats know what is there in their way, and they catch their prey or change their way. So this is the explanation.
But this is the first study to show how they recognize large flat objects like ponds. Stefan and Bjorn caught wild bats in Bulgaria and tested them in a large dark flight room. They presented the bats with either smooth or textured plates, positioned on the flight room's sandy floor. When presented with a smooth plate of metal, the bats treated it like water and tried to drink. Even when the metal plate was put on a table, a very unnatural position for a pond, the researchers watched as the bats attempted to quench their thirst. A smooth metal plate reflects sound in the same way as a body of water, so this behaviour supported the researchers' hypothesis that bats rely on the mirror-like echo-reflection properties of smooth surfaces to recognise water in their environment. When a bat flies above a smooth surface, most of the sound waves in its call are reflected away.
So look at
A
this.
small proportion hit the surface immediately below and then bounce back, a telltale sign of water if you're a bat. Stefan and Bjorn also tested young bats that had never encountered a pond or river before. These naive bats also tried to drink from the metal plate. This was the first time in their lives these youngsters had encountered a large smooth surface, so this suggests that water recognition in bats is high.
And here is the video of the dolphins.
After the dolphin takes a breath at the surface, air returns from the lungs to a series of nasal air sacs located below the blowhole. Although it varies between dolphins, there are four main pairs of air sacs. The nasal sacs are used to manipulate air pressure inside the spherical cavity and as acoustic mirrors, redirecting sound forward. The current hypothesis attributes primary sound production to the monkey lips dorsal bursa complex. Each bursa lies slightly below a ridge that protrudes into the spherical cavity. These ridges are the monkey lips.
So it is producing ultrasound waves.
Pressure from streams of air bubbles released up the spherical cavity from the lungs through the complex cause the anterior and posterior monkey lips to slap together. It is believed that the posterior monkey lips slap the anterior monkey lips like a hammer striking an anvil. The clicking vibrations are transferred to the dorsal bursa and pass on to the melon. The melon is an organ made up of specialized lipids that facilitate acoustic
So look now,
propagation of sound
ultrasound waves are producing,
this dorsal bursa complex.
and they work in the same way as the bats ultrasound waves work. So look now.
Once the sound is emitted from the melon and into the environment, it bounces off an object.
They are striking and coming back.
Echoes to the dolphin.
So how the dolphin will know there is something in the way?
Specialized fatty tissues within the jaw region serve as the primary route for picking up sound and transferring it to the middle and ears.
Okay, moving further. An ultrasound beam is also much more directional and can be aimed rather than like a torch. This has been used in ultrasonic spectacles for blind people. So this is the technique which is used by the dolphin and bats. The same technique the scientists are using for the blind people. So they are using a spectacle in which ultrasound waves will be produced, and if there comes something in the way, so the blind people will know that there is some kind of the obstacles. So look now, this has been used in the ultrasonic spectacles for blind people. The spectacles have a transmitter and a receiver. The receiver produces a high and low sound in the person's ear depending on whether the object causing the echo is near or far. So here is a video that will make your concepts even more clear. So look now, a blind person is moving. Here is a instrument that is producing ultrasonic waves, ultrasound waves. So look now.
If these bounce off objects in the vicinity,
And the person changed his way.
through vibrating buttons in the handle. Different buttons tell him where the obstacle is. The strength of the pulse tells him how far away. He knows immediately if an obstacle is there, and if he needs to change his course to avoid it. No problem.
So this is the technique that is used in case of the blind persons. A motion sensor uses ultrasonic echoes in the same way. You can use one with the computer to draw motion graphs. Echo sounding is also used to detect flaws inside the pieces of the metal. A transmitter sends out pulses of the ultrasound and receiver picks up the echoes from different parts of the metal and shows the results on the CRO, cathode ray oscilloscope. Pulse A is the transmitted pulse. Pulse B has been reflected by the flaw. So here is A, that is transmitted pulse. Pulse B has been reflected by the flaw B. So I will show you the picture now. Pulse C is the echo from the end C. So this is the technique how the flaws in the metals can be detected by using the echoes. Likewise, the geologists use echo sounding to search for the oil and gas. So here is a truck and here is a sonar that is producing ultrasonic waves. So if there is something into the ground, the sound waves, the ultrasonic waves will come back, and these persons in the truck or the technicians in the truck will know that there is some hard rock or oil and gas. Ultrasonic echoes are also used in medicines to see inside the body. This is safer than X-ray, which can be very dangerous. So look now, here is a person that is lying on the table, and doctors are using ultrasonic waves to see inside the body. Unborn babies can be seen by moving an ultrasonic transmitter receiver across the mother's stomach. Whenever a sound wave travels from one substance to another, skin, muscles, bones, some of it is reflected back to give echoes. The machine uses these echoes to build up a picture on the TV screen. So look now, this ultrasonic wave apparatus is producing a picture on the screen. This picture shows an ultrasound scan of an unborn baby 28 weeks after conception. So here is a picture that is obtained by moving the ultrasonic instrument onto the stomach of a pregnant woman. Can you see his face? So look now, here is the face of the unborn baby. Okay, here is another video that will make your concepts more clear now.
This video demonstrates how to set up and perform an ultrasound scan of the female reproductive organs. Equipment required includes the following: a standard floor model ultrasound machine.
So this is the machine.
Transabdominal and endovaginal transducers with covers and biopsy attachment as needed. A powered adjustable examination table with stirrups. Positioning aids such as pillows or sponges. An ergonomically adjustable chair. Acoustic and/or any water-based lubricant gel and gel warmers. Examination gloves. Bed linen and towels. And a sonographer's
So these
worksheet.
are the apparatus.
Select the standard preset
So,
for a
look
female
now.
reproductive system ultrasound. Ask the patient to lie supine on the examination table. Sit or stand on the patient's right side with the ultrasound machine on the upper end of the examination table. Expose the patient's abdomen and apply gel on the midline just above the symphysis pubis. Start the transabdominal examination of the uterus by performing a survey scan of the pelvic organs using the full
So
bladder
this
as an
is the
acoustic
thing,
window.
how picture is
Make the
produced.
necessary adjustments to the machine parameters to maximize image quality. Begin with the longitudinal plane scanning through the full bladder. Manipulate the transducer until a suitable image of the uterus, endometrium, cervix, and vagina is obtained. Starting with the midline uterine image, manipulate the transducer towards each side in turn and assess the uterus past its margins to the adnexa. Freeze the optimized image of the uterus as required. Annotate as to structure, scan plane, and scan approach. Measure the long axis of the uterus from the fundus to the cervix. Measure the anteroposterior.
This is the way how doctors see inside our body. Okay, moving further. The same method can be used to investigate heart and liver problems and to look for tumors. As you get older, stones can build up inside your kidneys. They are very painful. With ultrasound, they can be removed without having to cut open your body. The photo shows a high energy shock wave of ultrasound being used to smash the stones into tiny pieces. They then can come out with the urine, and ultrasonic beam is used because it is a narrow beam that can be focused at the right place. So this is the process how stones are broken into our kidneys that are produced. So ultrasonic beam is used because it is a narrow beam that can be focused at the right place only. Number two, it can transfer more energy than an audible sound wave. Okay, likewise, here is an other use of the ultrasonic waves. Opticians can use ultrasound to clean spectacles. The water inside this tank is vibrated by ultrasound at a very high speed. The vibrations shake the dirt loose, and the dirt become loose on the spectacles, and that can be removed easily. The same idea is used to clean jewelry, clothes, and even street lamps cover. Ultrasonic beams can also be used by dentists. The vibrations shake the dirt and plaque off our teeth. So you can ever have seen that some person's teeth are much dirty. So the ultrasonic waves can be used to remove the dirt and the plaque. So dirt and plaque move at very high frequency and they become loose, and how they are removed from our teeth. The vibrations are also used to kill bacteria in milk. Radar uses the echo sounding principle but with microwave instead of sound waves. It detects the position of the aircraft by measuring the echo times of microwave pulses reflected from them. So this is how police radars are used.
should change the longer.
Radar is the most common method.
So
of checking
radars
speeds,
are
with
used
about
on the highways
100,000
and
in
motorways
use
to
nationwide.
detect the speed of the
Two types of
vehicles.
radar are used. Stationary radar, often a handheld gun, is used from a fixed location. It's cheap, easy to use, and a tool of choice for motorcycle officers and city
So look
police.
now, the speed
The
can
second
be
type is moving radar.
detected.
It can be used in stationary mode, but also operates from a rolling cruiser. It has a control display unit on the dash and one or two antennas. With the front antenna, an officer targets approaching vehicles in the opposite lane.
So look now.
If the radar has a second antenna, it can also plot cars after passing.
So now the police is chasing a vehicle which is overspeeding.
Police and highway patrols.
So these are the techniques which are used in the daily life very nicely. So this was the second lecture of the sound, students. I hope so this will be much interesting and easy for you to understand. Read this lecture again, understand it, learn it, and make your notes. Thank you so much.